Hello guys, welcome back. Today's story, quantum computing. What is quantum computing? What is the use of quantum computing? What are the advantages and disadvantages of quantum computing? What is the future of quantum computing? Let's go. Quantum computing. Quantum computing is a cutting-edge computing paradigm that leverages the principles of quantum mechanics to process and store information. Unlike classical computers that use bits to represent either 0 or 1, quantum computers use quantum bits or qubits, which can exist in a superposition of states, representing both 0 and 1 simultaneously. This allows quantum computers to perform certain types of calculations much faster than classical computers for specific problems. Uses of quantum computing. Quantum computing has the potential to revolutionize various fields due to its unique computational abilities. Some potential applications include cryptography. Quantum computers can potentially break certain classical encryption methods while also enabling the development of quantum resistant encryption methods. Optimization. Quantum computers can efficiently solve optimization problems that are computationally expensive for classical computers, such as optimizing supply chains or financial portfolios. Material science. Quantum simultaneous can help understand complex quantum interactions in materials, leading to the development of new materials with desired properties. Drug discovery. Quantum computers can simulate molecular interactions at a quantum level, aiding in drug discovery and development. Machine learning. Quantum computing has the potential to enhance machine learning algorithms and data analysis by speeding up certain calculations. Advantages of quantum computing. Speed. Quantum computers can solve certain problems exponentially faster than classical computers, particularly in fields like cryptography and optimization. Parallelism. Quantum computers can process multiple possibilities simultaneously through superposition, allowing for massive parallelism. Quantum simulation. They can simulate quantum systems, which is crucial for understanding and designing new materials and molecules. Disadvantages of quantum computing. Technical challenges. Building and maintaining stable qubits is extremely challenging due to the factors like decoherence and noise, which can cause errors in computations. Limited applicability. Quantum computers excel in specific problem domains, but they are not faster for all types of computations. Error correction complexity. Quantum error correction is complex and requires additional qubits and resources, potentially reducing the advantage gained from quantum parallelism. Future of quantum computing. The future of quantum computing holds great promise, but it also faces significant challenges. Scaling up. Current quantum computers are still in experimental stage and have a limited number of qubits. Scaling up to create fault-tolerant large-scale quantum computers is a major challenge. Hybrid approach. It's likely that quantum and classical computers will be used together in a hybrid approach to solve specific problems more efficiently. Practical applications. As the technology matures, quantum computing is expected to find applications in cryptography, optimization, drug discovery, and other fields. Technological breakthroughs. New algorithms, error correction techniques, and hardware innovations are necessary for realizing the full potential of quantum computing. Scientific discoveries. Quantum computers could lead to breakthrough in understanding fundamental physics and simulating complex quantum systems. Summary. Quantum computing has the potential to bring about significant advancements across various domains, but practical challenges must be overcome to realize this potential fully. The field is still in its early stages, and ongoing research and development are essential for shaping its future trajectory. Thanks for watching. Subscribe for more videos.